So this unit, we'll move into chapter 20, and we're going to do a section on law of sines. So we had what's called right triangle trigonometry. Now we have something called oblique trigonometry. So an oblique triangle is a triangle that does not contain a right angle. So that right triangle makes things really, really friendly. But in the real world, not all the triangles that we create are going to be right triangles. Those are going to be called oblique triangles. Since these triangles do not have any right angles, like I said, we cannot use Pythagorean theorem or trigonometric functions directly. So what happens is, with some fancy dancing somebody did here, I'm not going to get into all their nice little cool work, but we're going to reap the rewards. We have this formula called law of sines. So the law of sines is going to be used to solve for the missing sides of oblique triangles, or missing angles for that matter. So the law of sines is actually rather easy. So notice how we have angle A and side A is opposite it. We have angle B and side B is opposite of it. We have angle C and side C is opposite of that. So notice how we have A over sine of A, B over sine of B, C over sine of C. So those corresponding pieces, angle A and the side opposite is going to be side A. Angle B and the side opposite is going to be side B. So we have that kind of relationship going on there. So the conditions for using the law of sines, when do we actually have to use this? Well, one, if we don't have a right triangle. If we have a right triangle, it's much, much easier to just deal with those basic trigs using the SOHCAHTOA. Here, though, if these conditions exist, then we will use the law of sines. So if two angles are known and a side is known, the law of sines is going to be used. Also talks about two sides and an angle opposite one of the sides is known. That's also going to be a way to do this. It does make a little note here, though. When using the law of sines, you must have at least one complete ratio, an angle and a side opposite. However, if we know two angles of a triangle, we can always find the third angle, because remember, the three angles of a triangle always add up to 180. Then we can form the complete ratio. So keep that in mind. In a triangle, angle 1 plus angle 2 plus angle 3 will always equal 180 degrees. So we have that back in our high school days of geometry. So let's look at this first example and see what we can do with it. So notice how we do not have a right triangle, I don't think. It doesn't look like it's a right triangle. But notice how we have two angles. We can find this missing angle up here by adding the two angles together and subtracting from 180. So if we have this 180 and we subtract in this 50 plus this 75. So this is going to be 180. 50 plus 75 would be like 125. So we have this 180 take away 125. Let's see if I get that back to where it needs to be. All right, come back here. We'll make this go back over here a little bit. Okay. So 180 take away 125. That's going to give us then 55 degrees. So angle C is now going to equal, oops, try that again. So angle C is going to equal 55 degrees. So we actually know all three sides right now. And we do know, we know side B at this point. So what's missing is side C and side A. Those are unknown. So let's start with side A. Let's look for side A. So to do this, A can be the only unknown. So if we have side A, then we have to use the sine of 50 degrees because that's the angle opposite that. And then over here, we just have to use a ratio that we do know. And we do know the B's. So I can use side B, which is 12, over the sine of 75 degrees. So what we want to do is solve this for A. I could cross multiply, but notice really all I really want to do is just multiply this way because I really want to just get the A by itself. So this is really going to be A equals 12 times the sine of 50 over the sine of 75. So remember, with portions, you can cross multiply, but I really only need to multiply that one across there. That would get my A by itself. So slide this back across here. So if I can put that into the calculator, notice how I'm in degrees now. So my mode on my calculator has to be in degrees, and I changed it. That's the hardest part about this, is remembering that you're going back and forth with your modes. So if I type in, then well, let's quit that. 12 sine of 50 degrees, hit enter. And if we divide that by sine of 75 degrees, that'll give me then side A is going to be then 9.5 if I round to the 10th place. So to find C, it's best to keep using the B relationship because it wasn't rounded. A was rounded. So to find C, we're going to have C over the angle, which is 55 degrees. So that's going to be the sine of 55 degrees. And we want to keep that B relationship going. So 12 over the sine of 75 degrees. So remember, we could cross multiply or really just multiply that one way. So C is going to equal actually 12 sine of 55 degrees over sine of 75 degrees. So again, that's a fraction. Notice how you can just type the numerator in and divide by the denominator, or you can put it all in at once, whatever your pleasure is there. This time I'll just put it all in one big spot. 12 sine of 55 degrees. On the bottom, the sine of 75 degrees. Hit enter. That's going to give me 10.2. 10.2. So the other missing pieces would be then C is the 10.2 and side A was 9.5. And then angle C was 55 degrees. That was the missing pieces in this problem. Notice that opposite the biggest angle should be the biggest side. So 12 should be the biggest side of all. It is. Notice how angle C was 55 degrees and angle A is 50 degrees. So side C should be bigger than A, and it is. So A is actually, since that's the smallest angle, side A should be the smallest side. So that's kind of checking out for us. So if we look at this example, if we want to find the missing pieces of the triangle, notice how, again, angle C is the first thing that jumps out at me, is that third angle. So remember, we have this 180, and we're just going to subtract the other two angles from that. So 35 plus this 40. So it's going to be 180, take away, what, 75? So it's going to be 105. So C is actually, it's actually an obtuse angle. So this is going to be, let's see what this does for us, since C is an obtuse angle. So first off, let's find side A. So to find side A, we have A, actually, take that's a different problem. On this one, we're looking for we actually know side A, we don't know side B, and we don't know side C. So we're missing side C as well. So we're looking, so angle C we've got, that's 105 degrees. What we're still looking for is side B, we don't know, and side C, we don't know. But we do know A. So let's start with just looking for side B. Side B will go with its opposite angle, which is the 40 degrees. So it's going to be the sine of 40 degrees. And then the known ratio is going to be the A's, the 7 over the sine of this 35. So notice how, again, we don't really need to cross multiply. We just need to multiply the other side by the sine of 40. So B is going to equal 7 times the sine of 40 divided by the sine of 35. So again, we could type that in as 7 sine of 40, hit enter. We'll close parentheses, hit enter. And then just divide that by the sine of 35. So you can do it that way if you want. And then you have B is 7.8. So now if we're looking for C, that's going to be C over the sine of 140. It's the sine of 105. And that's going to equal then, and let's keep that A relationship going because it's known to begin with, 7 over the sine of 35. So again, we just want to multiply that one diagonal. So C is going to equal then 7 sine of 105 over the sine of 35. So if we do that math, again, if you want to do the fraction alpha F1, number 1, we have 7 sine of 105. On the bottom, we have sine of 35. And then if we hit enter, that'll give us C is equal to 11.8 if we round to the 10th place. So B is 7.8 and C is 11.8. So notice how C was the biggest angle, the 105, so it should be the biggest side, 11.8. A was the smallest side, the 7 should be the smallest, and it is. B is actually a little bit bigger, so I feel okay with my math there. Alrighty, so that's a little bit about law of sines.